Okay, let's keep moving on our infinity square root equation. So in the last two videos, we talked about square root a plus go to infinity and square root a minus go to infinity. Today, our equation is first plus and then minus, and then repeat in turns go to infinity. Similarly, if we let the value of this number equals x, then the start point we can do is only the third square root. So we need to go one more further, go to the third square root, and then look at this number again. It still contains unlimited square root a plus and then a minus go to infinity. So it is actually still an x. So we can write this equation as x equals square root a plus square root a minus x. And we know x is greater than 0. If we let y equals square root a minus x, we know y is greater than 0. So the original equation can be written as x equals square root a plus y. And then this equation here, if we square both sides, we get x squared equals a plus y. And then similarly for this equation, if we square both sides, we get y squared equals a minus x. If this is equation 1, this is equation 2. 1 minus 2 is x squared minus y squared equals a plus y minus a minus x. So equals a plus y minus a plus x equals x plus y. While the left side of this equation can be written as x plus y times x minus 1. So for this equation, there are two solutions. First is x plus y equals 0, or x minus y equals 1. So y either equals negative x or y equals 1 minus x. Only situation this equation equals is a equals 0. So in that case, y is square root a minus x equals minus x. And then we square both sides, we organize it as x squared plus x minus a equals 0. Okay, and then for the second solution, we also know y is greater than 0, so y equals square root a minus x equals 1 minus x. We square both sides, get a minus x equals 1 minus x squared equals x squared minus 2x plus 1. And then we organize as x squared minus x minus 1 plus 1 minus a equals 0. And then this equation has two solutions. x1 equals negative 1 plus square root 4a minus 3. And then x2 equals negative 1 minus square root 4a minus 3 over 2. And we need to check these two roots. Here we know x is greater than square root a because x equals square root a plus y, and y is greater than 0. So if we check this, we know that x2 is actually less than square root a. So we need to reject x2. And then if x1 is greater than square root a, then we know that a needs to be greater than 1. All right, so a equals 0. We get the answers here. And when a is greater than 1, then the root is x1. Let's look at in the coordinate plane. This is a, and this is x. So the first equation here is going to look like, here is -1. Here's a equals 0, x equals 0. And then the second equation here is going to look like this. So a needs to be greater than 1. So when a is greater than 1, we actually use this part of the curve. Okay, after doing this, let's take a look at this example here. A equals 5 is greater than 0. So the root is x1 equals -1 plus square root 4 times 5 minus 3, which is 17 over 2.